Good morning, eighth graders. Today we are going to continue our study of the geologic timescale and how Earth has changed since it was formed 4.7 billion years ago until our present day. We talked on Friday about how, if you were in the Zoom class, how Earth started out without any of the gases in our atmosphere that we need to sustain life as we know it. It started out molten and very hot, devoid of any kind of life. And after a billion years, because of all of the volcanic eruptions emitting or pushing gases out into the atmosphere, and some water and in the form of ice entering into our planet via asteroids, it kind of kicked off the water cycle and it became a water world at that point. Okay, so it covered the earth that was once molten in water. As we move on, lots of other things changed. We had a couple ice ages, and then we talked specifically about, when I say moment, I mean a period of millions of years, 541 million years ago, that we refer to as the Cambrian explosion. And that was a period where things changed enough on Earth and in our atmosphere that it was much more like what it is today. And that gave rise to all kinds of life. And life started branching out in all forms. Okay? We move on to 245 million years ago, and we begin the age of the dinosaurs, and then finally the age of the humans. And all of these big periods of time that have these defining organisms that lived within them were kind of punctuated on either side by huge geologic events like an asteroid impact or an ice age. And that's how scientists have divided up our geologic timescale. Okay, so today we are going to begin, not finish, but just begin this online activity that I have posted on the Google Classroom. Okay, so what your job is today is to read through these first 4 pages, and it gives you an overview, a very brief overview of some of the major moments or major eras in our history, okay, and kind of what different organisms were around and what our atmosphere was like and what our temperatures were like. And I want you today to, if you go to slide 5, it gives you some instructions here, but I'm going to walk you through slides 6 and 7. Slide 6 and 7 take all of this time, 4.7 billion years, and they relate it to something we are familiar with, which is the modern day calendar. Okay, so what it does is it takes all of the time and stretches it out so you can kind of have a better visual in your head as to like how long, in terms of one calendar year, how long did the age of the dinosaurs last? Okay, or in terms of a full year, how long have humans been here on Earth? Okay, and it just helps you to visualize that. So on these 2 slides, 6 and 7, you are to drag these boxes over to fill in this chart. Okay, so I recommend starting with the date. Okay, so this is how many millions or billions of years ago before present. So you're going to find the biggest number, and in this case, it's going to be 4.55 billion years. All right, so we will drag that right into here. The next largest increment of time is 3.5 billion years. So we would drag that right here. The next would be 1.2 billion years. And then we've got millions of years. So 540 million years ago and 425 million years ago. All right, then over here, we are going to drag in the dates on our modern day calendar. So we start with January 1st and then just put these in order. So then it would go March 21st, September 22nd, November 18th, and November 27th. And then your job, I'll leave to you for this page, is to go back to this reading in slides 1 through 4 and find out what organisms are kind of the defining organisms, or what was happening, what geological event happened during this period of time. Okay, so to start with, obviously, Earth is formed. Okay, 4.55 billion years ago, it's formed. And that would indicate on our comparison, January 1st, right? Billions of years go by, 1 billion years actually goes by, and the water cycle kicks off. Okay, so that would give rise to the first single-celled organisms. Okay, so what this is saying is that if we took all of Earth's time and we put it into one calendar year, we wouldn't have even got the first single-celled organisms until March 21st of that calendar year. Okay, and so on and so on and so on. All right, so you're looking back at these readings to try to figure out where these things go. This timeline finishes on slide 7. Okay, so you continue. You continue on this page. We left off at November 27th, 425 million years ago, and this is just a continuation. Okay, so put your dates down. How many millions of years before present? What is that comparison for a modern day calendar? And what kinds of organisms go into these boxes? All right, that'll give you a nice picture of our geologic time, just a really general picture. And then on Tuesday, we will continue on with slides 8 and 9. Okay, so 8 is just more instructions. 9 is the part that we will work on Tuesday, and then we will finish up slides 10 and 11 on. Actually, I think the copy I gave you might not even have this one. I don't know. So we'll do this part on Tuesday, and then we'll finish up with the questions on the last 2 slides on Wednesday. All right, so we're going to kind of chunk this this assignment up a little bit, otherwise it could get a little bit long, and I'll give you a little bit more information, and we'll talk a little bit more about the geologic timescale on our Zoom meetings together. All right, I will talk to you soon.